Good morning everybody. We'll see about PLC program. As we all know, PLC is used widely in industries and it is very useful for automation. Now we'll see about a PLC program, that is a counter program that specifically uses add instruction. Okay, so this program illustrates how the add instruction can be used to add the accumulated count of two up counters. This application requires a pilot light to show the output or to indicate the output. That is, we have two counters and the count from the two counters, when it is equal to or greater than 350 value, the pilot light is going to glow. Source A of the add instruction is addressed to store the accumulated value of counter C5 is to 0, and source B of the add instruction is addressed to store the accumulated value at the counter address C5 is to 1. The value at source A is added to the value at source B and the result is stored at the destination address N7 is to 1. So we will be able to understand this clearly in the next slide when we see the diagram. Source A of the GEQ is greater than or equal to instruction is addressed to store the value at the destination address N7 is to 1. Source B of the GEQ contains the constant value of 350 degree. So 350 degree is the count that we require. So here it is taking the constant value of 350, which can vary according to your program. The GEQ instruction and PL1 output will be true whenever the accumulated values in the two counters are equal to or greater than 350 degree, which is the value that we have set. A reset button is provided to reset both the counters. Now we look at the diagram. Okay, so this is the diagram. So it has two counters, up counter 1 and up counter 2. Let us have it as up counter 1 and up counter 2. The counter addresses are C5 is to 0 and C5 is to 1. And here we have two switches S1 and S2, and these are going to count the components. So now what do we require is, we require that the components of these two should be added and it should be here, and it should be compared with our required value of 350. So if it is greater than or equal to the value of 350 degree, we have set it like the pilot light will. So now let us see, a component comes here and this S1 is triggered. Okay, so what will this up counter do? This up counter will start incrementing from 0. It will go to 1. Okay, so now if another component or another signal, let it be component or any signal, if it comes, this counter is going to be incremented. So if it is at 0, it is going to be incremented to 1. So likewise, if S1 is activated, this counter is going to get incremented. If S2 is activated, this counter is going to get incremented. So the preset values of both the up counters are kept to 350 degree, which is our desired value. This 350 can be varied according to your necessity. So for me, I want the total count of the components or the signals to be 350. So I have set the preset value of both to be at 350. So let me assume, here when component comes, it becomes 1. Here when component 1 comes, it becomes 1. Here the second component comes, it becomes 2. Here the second component comes, it becomes 2. Okay, here it comes, it becomes 3. Here it comes, it becomes 3. Like in any order, the counter values keep on increasing. Okay, so as and when the counter values keep on increasing, those values are going to be updated here as well. Here you can see source A, suppose it is 3, source B, suppose it is, suppose it is 4. So these two values are going to be added. 3 plus 4, 7, or 3 plus 5, 8, or 3 plus 9, 12. So these are going to be updated here. Okay, so these two values gets added and it is going to be updated here at the destination address N7 is to 1. Okay, so this N7 is to 1 also gets reflected, or it is also connected to GEQ, that is greater than or equal to source A here. Okay, so suppose, let me assume, here 3 and 4. Okay, that is 3 components from here and 4 components from here. 3 plus 4, it becomes 7. So this 7 is going to be compared with source B. So obviously 7 is not greater than 350 degree. This pilot light is not going to glow. So let me assume the signals are coming, or let the components keep on increasing. At one point of time, if my addition value. Let me assume it as 250 plus 101. 250 plus 101 or something, and it exceeds the value of 350. Let me assume my value here is 351. So 351, when it is going to be compared with source B, 351 is greater. So this greater than or equal to block is going to send an output which is going to activate the pilot light. Okay, so the pilot light is going to glow, which indicates that I have received the number of signals, or I have received the number of components which is greater than or equal to 350 dB, which is the required set point. Okay, so I have set it to 350, maybe I can set it to 400 or whatever is my requirement. Okay, so now the pilot light is glowing, which is my requirement. After that, since I am using two timers, I'll have to reset them in order for them to become active again, or in order for them to start working again. So what do? I use a special button, reset button, and I'm going to reset these two timers. On resetting these two timers, what will happen is the accumulated value, let it be 100 or 200 or whatever is present here, will become 0. The same way here also it will become 0. So now my system becomes new to be used again. So these are S1 and S2. These S1 and S2 can vary depending on what application you use. Suppose you want to count the signals, they can count the signals. Suppose you want to count the number of components, it can count the number of components. So basically S1 and S2 are normally open switches. Okay, then you have a reset switch here, which you are going to press it manually to reset your counters. That is, once the pilot light goes on,